Hello everyone, I am Latarani HM, Assistant Professor of Mathematics, GFGC, KR Nagara. In this session, we discuss about differentiability of a complex function. Definition: a function f of z is said to be differentiable at a point z is equal to z0 if limit z tends to z0 f of z minus f of z0 divided by z minus z0 is exist. This limit is called the derivative of f of z at z is equal to z0 and it is denoted by f dash z0. Therefore, f dash z0 is equal to limit z tends to z0 f of z minus f of z0 whole divided by z minus z0. Now, by putting z is equal to z0 plus delta z, then we have delta z is equal to z minus z0. Then the above formula can also be written as another form f dash z is equal to limit delta z tends to 0 f of z plus delta z minus f of z whole divided by delta z. Differentiability of a complex variable means we are using the two formulas. One is f dash z0 is equal to limit z by z0 f of z minus f of z0 whole divided by z minus z0. Otherwise, we can also use this formula. Now, we discuss about some problems on differentiability. First problem, find the derivative of f of z is equal to z cube at z is equal to z0. This problem is solved by using both the formulas. Solution. Here I consider the first formula. By using first formula also we can solve, and also other formula we solve this problem. Write the formula of the differentiability. F dash z0 is equal to limit z tends to z0 f of z minus f of z0 whole divided by z minus z0. This is the formula of the differentiability. Here f of z is z cube. Therefore, find the f of z0 value. Put z is equal to z0. We get z0 whole cube. We are substituting here f of z is z cube minus f of z0 value is z0 cube whole divided by z minus z0. Now, here z approaches to z0 means we are putting z is equal to z0. When we are putting z is equal to z0, we get 0 by 0 form. Therefore, we are using the L'Hospital rule. Otherwise, we can also use the formula of a cube minus b cube formula. Otherwise, L'Hospital rule because of 0 by 0 form. L'Hospital rule means we can differentiate numerator and denominator separately with respect to the variable z. Therefore, differential of z cube is in a 3z square minus here z0 is in a constant. Differentiation of constant is a 0 whole divided by differentiation of z is 1 minus 0. Therefore, 3z square divided by 1. Now put z is equal to z0. We get 3z0 whole 3z0 square. Another problem. Find the derivative of f of z is equal to z minus 1 whole divided by z plus 1 at the point z is equal to 2 minus I. First we write the f of z value. Here in the previous problem f of z is in a simplest form, but here we have z minus 1 divided by z plus 1. Therefore, first we find out f of z not value and then substitute in the formula. Let f of z here z minus 1 divided by z plus 1. Therefore, f of 2 minus I is 1 minus I divided by 3 minus I, because put z is equal to 2 minus I. 2 minus I minus 1 is a 1 minus I whole divided by 2 minus I plus 1, that is 3 minus I. Now consider the formula. F dash z naught is equal to limit z tends to z naught f of z minus f of z naught whole divided by z minus z naught. Here already substitute the z naught value. What is z naught value? 2 minus I. Now substitute f of z value. F of z value is z minus 1 whole divided by z plus 1. Z minus 1 divided by z plus 1 minus f of 2 minus I. We already find out that value. Just substitute here 1 minus I divided by 3 minus I whole divided by z minus 2 plus I. Here LCM as z plus 1 and 3 minus y. Take the LCM, then multiply, we get z minus 1 into 3 minus I minus of 1 minus I into z plus 1 whole divided by z plus 1 into 3 minus I into z minus 2 plus I. Now simplify the numerator. After simplification we get 2z minus 4 plus 2i whole divided by the denominator. Here 2 is in a common. Take 2 as outside. Remaining is z minus 2 plus I. This z minus 2 plus I will be get cancelled. Remaining is 2 divided by z plus 1 into 3 minus I. Now substitute z is equal to 2 minus I. When we are substituting z is equal to 2 minus I, we get 1 whole divided by 4 minus 3i. Here we can express is in the form of complex variable. Complex variable means it is in the a plus ib form or a minus ib form. But here I is in the denominator. Therefore apply the rationalization. Here rationalization term is 4 plus 3i. So multiply and divide rationalization term 4 plus 3i. Therefore 4 plus 3i whole divided by 4 minus 3i into 4 plus 3i. In the denominator we get 4 square plus 3 square. 4 square plus 3 square means 16 plus 9 gives 25. Therefore the derivative of f dash z naught is 4 plus 3i whole divided by 25. Here we have one theorem. If f of z is a differentiable at z is equal to z naught, then f of z is continuous at z is equal to z naught. Or it simply called prove that f of z is a differentiable at z is equal to z naught, then f of z is continuous at z is equal to z naught, and the converse need not be true. Proof: by the data f of z is differentiable at z is equal to z naught. In this theorem they given f of z is in a differentiable at the point z naught. According to the definition of differentiability, we can write f dash z naught is equal to limit z tends to z naught f of z minus f of z naught whole divided by z minus z naught. This differentiability exists and also it is unique. Therefore, consider limit z tends to z naught f of z minus f of z. In this theorem, we can prove that every differentiable function is continuous. Therefore, first we consider the differentiable function. Limit z tends to z naught of f of z minus f of z naught. Now we are comparing with the differentiability definition. Here, for this equation, we can multiply and divide by z minus z naught. We get like that. Limit z tends to z naught f of z minus f of z naught into z minus z naught whole divided by z minus z naught. According to the properties of limit, limit of f of x into g of x can be written as limit f of x into limit of g of x. Then z approaches to z naught. Suppose if you apply z is equal to z naught here, then we get the 0 by 0 form. So we cannot apply z is equal to z naught in this case. We are applying only for the second term. Put z is equal to z naught here. Z naught minus z naught gives 0. And this one, limit z tends to z naught, f of z minus f of z naught whole divided by z minus z naught can be written as f dash z naught. So f dash z naught into z naught is equal to 0. That is limit z tends to z naught, f of z minus f of z naught is equal to 0. Again, by the property of limit, limit of f of z minus limit of f of z naught. Here f of z naught is a constant. After applying the limit, we get the same function, that is f of z naught. Therefore, this can be written as limit z tends to z naught, f of z is equal to f of z naught. Hence, this shows the condition of the continuous function, the last condition of the continuous function. Hence, the given function f of z is continuous at z is equal to z naught. Hence, we conclude that every differentiable function is a continuous function. Now, converse part. The converse of the above theorem is not true. Means, every continuous function need not be a differentiable. For example, f of z is equal to z bar. By using this example, we can prove the converse part. Means every continuous function not be a differentiable. Let us consider here z is equal to x plus iy and z bar is x minus iy. Therefore, f of z is x minus iy. Apply the limit. Along x-axis, y is equal to 0. Therefore, limit x tends to 0 of x is 0. Then consider the y-axis. Along y-axis, x is equal to 0. Then limit y tends to 0 of z bar is equal to minus I into y. Here y can be approaches to 0. Again value is 0. Here limit value gets 0, means it is in a unique. Therefore, limit is exists and it is continuous. Now, consider differentiability function, that is f dash z is equal to limit delta z tends to 0 f of z plus delta z minus f of z whole divided by delta z. This is the another form of the differentiability formula. That is limit delta z tends to 0. Here f of z is z bar. F of z is z bar. Therefore, z plus delta z can be written as z plus delta z whole bar, means conjugate function of z plus delta z minus f of z. What is f of z? Z bar whole divided by delta z. We know that z is x plus iy. Z bar means what? X minus iy. Here z plus delta z, that can be written as x plus delta x plus I into y plus delta y whole bar. Its conjugate is minus I into y plus delta y minus z bar value is x minus iy. Simplify this function, we get delta x minus I into delta y whole divided by delta z value is delta x plus I into delta y, because z is x plus iy, delta z is delta x plus I delta y. Again, here we see in the two cases, one is along x-axis and along y-axis. If delta z is real means if the x-axis along the x-axis, then delta y is equal to what? 0. Therefore, delta x tends to 0. Limit delta x tends to 0, delta x whole divided by delta x, because here delta y is 0, substitute delta y value 0. Delta x by delta x is 1. And along y-axis, that is if delta z is imaginary, means y-axis, then delta x value 0. Therefore, f dash z can be written as limit delta y tends to 0, delta y divided by I into delta y minus I delta y and plus I delta y. I delta y get cancelled. we get minus 1. Here limiting value does not unique. Since the limit is not unique, hence the given derivative does not exist. Therefore, f of z is not a differentiable. Thank you.